Here's question number 7 on the quiz of sequences. In one section of an auditorium, there are 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. There are 50 rows. Then, part A says, write first 5 terms of the sequence. Part B says, write general term that determines the sequence. And C, how many seats are there in 50th row? I'd like you to answer the question, and once you have answered, then you can see the video to check your answers, right? Now, here is my solution. In one section of auditorium, there are 20 seats. In the first row, 22 seats in the second row, 24 seats in the third row, and so on. And there are 50 rows in all. So part A is write first 5 terms of the sequence. So the sequence really starts from row 1, which has 20 seats. So we can write like this, right? 20. Next is 22. And then it is 24. It's going up by 2 each time, right? So the next term should be 26, and 26 plus 2 gives me 28. So like this it is going on. So these are my first 5 terms, correct? Part B, write general term that determines the sequence. Now, how to write a general term? That is definitely a huge question. Now, for that we need to analyze our pattern. So here we see that if we move from first term to second term, then we actually add 2, right? And then again we add 2. So each time we are adding 2. It's a linear relation. So when you add same quantities each time to get the next term, the relation is linear. If you plot them, you'll get a straight line. Now here, since the difference is 2 between each term, we actually call it common difference, right? So we say common difference is 2 in each term. So 2 has something to do with the formula, right? So what it is. So basically what we do here is we try to relate term number with the term value. This is our term number 1, first row. This is our term number 2, second row. This is our term number 3, third row. This is term number 4, and this is term number 5. Like this we have at the most 50 terms, right? And somewhere in between we can say n terms, correct? It's something like this. Now 2 times 1 is just 2. How will I get 20? I can get 20 if I add 18 to it, right? 2 times 2 is 4. How can I get 22? I can get 22 if I add 18 to it. Do you see that? Yes. Sometimes it's good to find what could have been the value at the 0th term here, starting value. So if I do 2 minus, I'll get that value, and that value could have been 18. Do you see that? That's the magic number. So this kind of gives us a hint on what the equation should be. If you remember the line equation, y equals to mx plus b, where b is the y-intercept, the value of the function at x equals to 0. So that is the 0th term. Do you see that? 18. And this is kind of slope too. And therefore, that gives us an idea. Write general term that determines the sequence. So we say general term Tn is equals to 2 times n plus 18, where 18 is our 0th row, a row before the first, to which we will add 2 each time. Do you see that? That's how you can get your formula, okay? So related to y equals to mx plus b, where b is the y-intercept, and we get y-intercept at x equals to 0. Remember one more thing, sequences n is always natural number. That is 1, 2, 3, 4 and so on, never 0. Okay. Now, here we are. We can test this. If I write 4, 4 times 2 is 8. Correct? And what is 8 plus 18? 26. We get it. Do you get it? Yes. How many seats are there in 50th row? So we'll write T50 here and calculate. 2 times 50 plus 18. And that gives us 100 plus 18, which is 118. Okay? So that's our answer for the seats in the 50th row. Correct? So what do you learn here? You learn if there is a linear sequence, right? In that case, the formula to use is, let me write here in a box, y equals to mx plus b. Okay? Where b is kind of y-intercept when x equals to 0. Okay? Great. I hope you learned from this and you can solve such problems very easily. Thank you.